All right, before we begin, let me mention the outline of today's section. First of all, we're going to get started by filling in the form. We can fill in our name, age, country, and so on and so forth. And after we submit the form, our form is going to be submitted into our NEO4J database. This database is actually running on the cloud, so we have to access to it through the given password, username, and the other things. I'm going to show them to you in detail step by step. Just stick through it. And after we access the database, we will have like the access to the same database, and we will be writing the queries all together. And in the third section, we can just discover some interesting patterns, answering some questions, like learn how Neo4j works, and learn a little bit about Cypher syntax. All right, without further ado, let's get started. So I'm gonna go ahead and fill in the form. I actually want to mention something real quick. By just going to the documentation, I came to know that actually they provide a driver in JavaScript. So I have a front-end running web app here with Vue.js. It's totally fine if you use like React or Angular. Any other frameworks are fine. You just do npm i neo4j. It's gonna install, and you can just use it in your JavaScript applications. And you just have to provide username and password. In my case, I did it here. It's loading actually through the my environment variables, but I'm gonna provide that to you so that you will have the access to the database that we have on the cloud. All right, so I'm gonna go ahead and start filling in the form. This form is actually running on my database. So what's your name? I'm gonna answer Roma. How old are you? 23. I live in Dongguan, let's say. And what's your favorite? My favorite programming language is Python. I think I'm an intermediate coder, so I'm just gonna write intermediate. I'm from Uzbekistan. And after we submit the form is gonna be submitted into our database on the cloud. All right, so we are about to finish our first step here. And actually, I console logged the query that is being executed when we press the submit button. So if you don't understand what's going on here, that's totally fine. And by the end of today's video, I think you will learn how they work and stuff like that. All right, so now we are moving on to the second part. We have to access our database. In order to access our database on the cloud, you just go for neo4j.com, and there you can just click the button and get started for free. You have to actually create an account. If you don't have one, just go ahead and feel free to do that. So I have already registered, so I should have an account already running on the cloud. And after you register, actually there are instances. So you can just create a new instance. And after you create an instance, just you may want to have the same page, but with your own instance. But there will not be any nodes. That will be empty with the relationships because you don't have anything in your database, and it's totally fine. But when you click the open button here, it's gonna show you the URL and like database user and password. So I'm gonna provide you the password. You can copy the password and also the URL. And after you copy paste those, you can just click the button connect. And after this step, you are gonna have access to our database running on the cloud. So you should get something like this, the same as mine. All right, now we have accessed our database, and from here we can get started with writing some queries. Actually, before we begin, I want to mention something very important here. You have to understand what a label, what a property, and what a relationship is in this section. So let me just go through them quickly one by one. Label. What is a label? Label is just a name that we give to our node. So we have nodes and the relationships, right? So every single node has a label here. For example, Roma, Mohammed, and Stella, they have a label of, let's say, students. So these are names, so I'm assuming that they must be students. So I have here Python and C in red nodes, and their label must be programming language because they both belong to programming languages, right? And here over here in yellow, we have Zhongguancun, and actually it's a campus in Beijing, right, for our university. So it's the node here, and its label is campus. And we have properties like next. What is a property? Actually, everything can have like properties or nodes and as well as relationships. Okay, for example, for Roma node, it can have a property of age, or let's say country. Everything that belongs to Roma will be a property of Roma. If you code it in Python or any other languages, you just create an object, right? Object can have functions and as well as properties. So this property is just similar to what we have in other programming languages. And we have relationships. So for example, Roma lives in Zhongguancun. It's kind of relationship that represents Roma's location, right? So Roma lives in Zhongguancun. Roma likes Python. And these relationships can also have properties. I will show you them to you when we start writing some queries. All right, so let's go ahead and start writing some queries. First of all, we are gonna, if you are familiar with SQL, you will do something like select everything and return everything, right? In cypher syntax, we have something called match. So when you do match and return return the variable here, it will select everything in our database and it will return it to you. So we are selecting everything and returning everything. So match actually stands for select in SQL. We are just selecting everything in our database. So when we take a closer look at our nodes, actually not only me who's filled in the table, the form here, actually so many students have filled in the form, so we have their own their information as well, so we can just play around with this data set that we have. All right, so now it's returning everything to me, but I want to return specifically, let's say, only the campus. So in this step, we will need the label. So each node has a label. So our campuses has a label of campus. So in order to access that, I'm going to do this the colon here, and then access to the property, access to the label. All right, so far we've filled in the form and we submitted our data to our database on the cloud, and we've seen how to connect to it through NEO4J cloud database. We've put it the password and the URL. Now we have access to our database, and from this step, what we are gonna do, we are gonna execute some queries, and we also got to know the nodes and the relationships they have and how they actually connect with each other, right? Now from here, the next thing what we are going to talk about is read. Read is actually stands for fetch, right? We can fetch data. We can just read data from the database. If you worked with APIs, you can make HTTP requests to the server, right? You can get data, you can like put data, delete data, and so on and so forth. So in Neo4j, how do we actually read data? We can read all the data in the database, or if we want, we can actually filter or get specifically something that we want. And we have a couple of questions and some like interesting patterns to discover along the way. And today's first question is going to be how to get all the Chinese students. So we have students in our database, right? If we click that, actually I'm going to get rid of the limit clause because it only gives me 25 students. When I do that, I can see all the students in our database. So we have 44 students, but that's not what I want. What I want is I only want students who are from China. How do I do that? So I need to sort of filter my data, right? I don't want all the students, but I want to filter for specifically students who are from China. So I'm going to introduce you a new keyword today, which is where. You actually use the where like when you want to filter, when you want to get something that you want. Not all of them, but specifically the students who are from China. So we named our student N, so I'm gonna go ahead and access their country property. So the country of the student must be equal to China. So as long as this condition is satisfied, it gives me all the students, right? And I can return it at the end. And when I run this query, I will get I get 10 students. All right. So actually, this is the first way of filtering data. Actually, you can do it in another way as well, which is my favorite way of doing it. So what you can do after you select the student, you can put the curly braces, and then you need to access the property. So student property has a property called country, and I'm gonna put colon, so it's like key and value. So I'm gonna mention the key first, and the value is a string value, and it needs to be China, right? And if I run that, I should get the same thing. All right. So there are two ways of filtering data, okay? You can use the where clause if you want, or you can just put it here inside the parentheses when you match. All right, so the second question that we are gonna answer, how to get multiple set of nodes. I only don't want students, okay? Or let's say I wanna get students and also, let's say, programming languages, right? When I match, I go like SD for a student, and I can put a comma here and open another parenthesis, and I can mention the programming languages. And I do programming language, and I can just return them, SD and PL. If I do that, I can just return all the programming languages. Again, we can just filter if we want to. We can like select SD dot, let's say country is equal to China, and let's say we want to get students from China, and we only want to get programming language, which is Python. So we can do and PL dot name is equal to Python. If we do that, we should not get 11 programming languages and 44 students. Instead, we will get 1 programming language and 10 students. All right, so that's it. I think it's pretty straightforward, and let's move on to the next one. How to get students in Liangxiang campus. So if we take a look at the campus here, we actually have 2 campuses, right? We have Liangxiang campus and then the Zhongguancun campus. And if I want to get all the students with their relationships, I can do something like this. I can do match SD for a student and the relationship. Do you still remember how we actually access the relationship? We put a dash, and then we will put like the brackets here, and inside the brackets we can specify our relationship. So lives in, and I can another parenthesis, which is another node, and I'm gonna put campus. I'm gonna name it cam, and I'm just gonna put campus here, and I can return SD campus. It's gonna return the campuses and as well as the students. If I wanna get their relationships, I need to actually name my relationship, right? So lives in, I'm just gonna call it rel, and I'm gonna return it as well. Now if I do that, I need to get the relationships as well. So these are 2 campuses and the students who live inside those campuses. Now actually we need to answer how to get students in Liangxiang campus. So we need to access our campus, and we need to get only the one which has a value of Liangxiang in their name, right? So I can filter for where. I can actually use where, but I don't want to do that. I just want to go with the curly braces one. I'm gonna access the campus's name property, and I'm gonna put a colon, and it should be equal to Liangxiang. If we do that, we should get all the students who live in Liangxiang campus. So that's how you actually filter for like relationships, okay? So you just need to give a name for your relationship. This is your variable now, which defines the relationship. and you can return it. So these arrows are actually the relationships, and we only got the campus, which has a property name with the value Liangxiang. I can even do Zhongguancun here if I want to, and it only gives me the students in Zhongguancun campus. All right, so let's move on to the next question. How to get advanced coders in specific programming languages? So we have programming languages, and actually this is a really nice question to talk about, actually, properties of relationships. If we go back, as I told you, every single node has a property, but also the relationships can have properties, okay? So in our database, our this likes relationship has a property, and also classmates with has a property, like they have a property of common class. We're gonna take a look at it later on. Now let's first get the advanced coders in specific programming languages, okay? So how do I do that? Actually, want to select the student. I don't want to search for the lives in relationship. Rather, I want to search for the likes, okay? And student doesn't like the campus, of course, so I'm gonna get rid of that. So I'm gonna put here the programming language, PL, programming language, right? And if we do PL here, and if I just execute this query, I'm gonna get all the students, and as well as the programming languages that they like, right? So some people like Java, and we actually don't want all of them. We want to filter. So if I do Roma, for example, if I click the relationship has a property of coding level, and it's set to intermediate. So we want to filter for that, and we want to get only the intermediate coders, okay? Let me just go and use the where clause this time. So I'm gonna access the relationship dot coding level. I'm gonna access to that, and it should be equal to advanced. And let's see. Actually, we don't have any advanced coders in our database, and let me do intermediate. I'm gonna go ahead and search for the intermediate one. Likely we have a couple of intermediate coders. So some people have the level of intermediate in C programming languages, and some people are intermediate in Python and SQL. Actually, the students submitted like our data is not like cleaned yet, so I'm pretty sure there were some misunderstandings when they submitted the data. So let's just take a look at, I want to explore the data a little bit at this part. I want to see actually what every single student chose as the coding level, okay? So I don't want to filter for anything. I want to return the relationship dot coding level. This way I can just see what every single student has inputted to the level of the programming languages. So as you can see, some people just put 1, poor, more than enough, junior. Actually, we can clean the data a little bit. So we can put the weak ones as beginner, kinda good ones as like intermediate, zero, we can define it as beginner as well. Yeah, as well. Top one. Oh, actually top one can be an advanced student, right? So we can actually modify this data when we get to update part, okay? We can update those to another value. All right, so this is how we do it, how to get advanced coders in specific programming languages. And next part we will talk about is update, okay? And this is all for the read section, and I will see you in another section. All right, so this is the update part of today's section. In the last section, we had a look at the students' programming coding levels, right? So when we executed that query, it gave us so many values, but they kind of were messy, right? So we had to clean a little bit of data. So when we clean data, we often update data, right? We need to change the values So for example, I don't want to put low. I want to stay consistent, so I want to put them as beginners, right? Actually, before we start updating data, actually, let's talk about why we actually use update, right? So as I just told you, we need, when we clean the data, we can update some of the values. We can change the values, right? So what we can update properties. We can update their relationships. We can update like the labels. For example, we can change student to something else. We can change the campus maybe to a location or something. So we can change our properties and the labels, and as well as the relationships. Before we actually start, I want to go through some aggregate functions, okay? Let's say I want to know how many coding levels are there in total. So I want to put them in a function called count. So count is something that you used. It's an aggregate function. So you put whatever value you want inside, and it will count for you how many actually values there are. Okay, so there are 44 values at the moment for the coding level. So but we only want 3 of them, right? So we want beginner, intermediate, and advanced, right? But instead of 3, we have 44 now, so we need to clean it a little bit. And I'm just gonna do a little bit of part of it. So if you have the access to the database, you can play around and you can do a little bit of help to me to clean the other parts. So when I actually display the PL coding level, I have so many values. I actually want to distinct them because I don't want to get duplicates. So when you put distinct, it only shows you the distinct ones, like the it will show you like each value without any duplicates. I actually don't like the way it's returning me rel.coding level, so I actually can name it as coding level only. Coding level. So you actually use drivers or APIs to access to your database, right? And when you when you get data from the server, from the database, you don't want something like that. So you put just the as keyword and specify whatever the name you want to give it. So in this case, I want to give it a name of coding level. So I have the coding levels here. So I want to change the low into beginner. How do I do that? So I need to select the ones which have a value of low first. Okay, I do where rel.coding level is equal to low, and after I get those, I want to update. So when you want to update something, you put the key value set. Okay, I'm sorry, I just put there. I thought it was another programming language. So it's normal. So we need to use the keyword called set when we want to update. We want to update their coding level from low to, let's say, beginner, right? So now I got all the students who have a coding level of low, and I'm changing the value of low to beginner. All right. So when I execute this, now it only returns me the beginner. Now when I get rid of where clause, when I return all the coding levels, so now here instead of low, I see beginner. I don't see any low anymore. So I change that, and feel free to change these ones into beginner. And for example, someone put newbie, and you can change it to maybe advanced, right? And middle ones to intermediate. Yeah, so this work is left for you, so I'm not gonna do that. And what else can we update? We can update actually the label. Let's say when we get the students, I actually want to get myself. Actually, this limit clause is used when you want to limit. It only gives me 25. Like if I change it to 5, I only get 5 students, right? So you might want to use it when you do the pagination, like on your application. You have a web app or a mobile app running, so you have like a pagination part, page 1, page 2. So you want to retrieve only 5 nodes at a time. So you might want to use limit at this time. And I don't want to use limit now. I want to get Roma. I want to give it a name of Roma. Roma is a student, and I want to filter for myself. So I need to put the name Roma, and I'm going to return Roma. I'm going to return Roma. And I want to update my label, so the node label from student to, let's say I want to update this to presenter maybe, or like an how do I name it? I want to change it to lecturer. Let's say I'm giving a lecture today, right? I can actually use the set word again. I put set Roma from student to Roma to lecturer. So I'm being a lecturer for 1 day, so I'm just gonna change it to a lecturer. Why did we get any? It says invalid input. Maybe I just need to put the lecturer here. Lecturer. Yeah, so sorry for the typo. And if I do that, it should work now. So Roma has a label of lecturer and as well as the student. So we have 4 labels at the moment now. And only we have 1 lecturer at this moment. I can actually get rid of student label, but I don't want that. I'm actually a student. I'm just a lecturer for 1 day, so I'm just gonna leave it. All right, so this is how we update the label of the node, right? Next, let's see how we can actually update relationships, all right? How do we update a relationship? Which relationship can we update? Let's say I want to change I want to retrieve all the relationships that I have. Let me retrieve all the relationships. And I'm just gonna call it rel, and then I'm just gonna call m for the all other nodes. Roma, rel, and all the other nodes. Let's take a look at that. So I'm classmates with people, and I live in Zhongguancun campus, and I like Python. So let's say I wanna change to Python, right? So I want to update the relationship, or let's say I want to update first. I want to update the intermediate to beginner. How do I do it? I just again use the set keyword. Set relationship. It's a property of a relationship, so we need to access the likes relationship, right? So relationship. You can even do rel. It will like check all the relationships and then it will like look for the ones which has a property of coding level. You can even do that, or if you don't want to do that, you can actually specify likes here, but I just want to, for the sake of simplicity, I'm just gonna put it like this, and I also want to return it all at the end. So I'm not gonna change anything here. The relationship.coding level equals to let's say beginner. All right. So if we take a look at my programming language now, so I like Python, and I want to see the relationship. Now, as you can see, I have a beginner level of coding. Yeah, this is how we update the property of a relationship. Now I want to update the relationship itself. I want to point to C, let's say. But I think in order to do that, we need to use the create clause, and then we need to kind of set. Actually, when we update a relationship, when we change the relationship, in order to do that, we cannot just point at another node. We need to create relationship, okay? So we need to create relationship and delete this one. I think we will talk about that when we get to the create section of today's episode, okay? And that's pretty much it. I think I didn't forget anything. I actually have like some more aggregate functions, like we can do match SD all the students and return. Let's say we have aggregate functions, right? We have mean and we have max and we have average. Let's say I want to find the average age in our class, so I'm gonna go st.age. So when I pass this, it's gonna show me the average age. It's a floating number now, but you can change it to integer. You can parse it if you want, but we just stick to simplicity for now, and we're not gonna do that. And I can do min and st.age. So when you do that, you should get the youngest student in our class, which is 1. Weirdly, someone inputted 1 as their age, and max 32. All right, so far we've read data, we've updated data, and at this part of the video, we are gonna talk about how we can delete data. So we're gonna delete some nodes, relationships, or properties, okay? And I hope you've been following along, and if you came across with sort of any bug, or if you got stuck somewhere, just feel free to reach out to me, and I'm more than happy to help you out. All right, so let's go ahead and try to delete some properties. Actually don't want to delete anyone's property, so I only want to play around with my own data, since I think it might be a little bit rude to kind of delete someone else's data. So if you are following along, and you just go ahead and match your own data first before you delete. And now I can only interact with my own data, so that I don't touch any data that doesn't belong to me. All right, I actually want to run this query first and see what I get. I got like myself and all the relationships that I have. All right, I'm a classmate with all the people here, and I live in Zhongguancun, and I like Python, right? First of all, I want to get started deleting some of the properties. If I click Roma here, you can see I have a property of age, name, and created. Created is like it's an integer value. The database gives itself when you create a data, so that it can identify when exactly the node has been created. We don't have to worry about that for now. So I want to delete the age property. Actually, when we delete, we want to be kind of careful, because let's say there are 2 people with the name Roma, right? So I might delete the age property of Roma for 2 people, but I don't want to do that. So I might want to use the ID instead. ID is something that the database gives you, and it uniquely identifies you, all right? So here, I don't want to search for Roma. Since I know my ID, so I can just do this. You can do where. There is an ID function that you can pass. I want to pass the variable Roma, which is a student, and ID of it should be equal to 2, right? And when I run this query, I should get the same thing. But I only got myself at this point with the ID, so I don't touch any other Roma's data, okay? Actually, you can also set an like constraint if you want, just like in SQL, but we're gonna talk about that later on. All right, so I want to delete the age property. So how do I do that? I go ahead and say remove Roma.age. As simple as that. Just the remove clause is used for deleting properties, whether it's a property of a node, whether it's a property of a relationship, okay? All right, so let me run this query and see what happens. So I deleted Roma's age property. Now this is what I'm left with so far. And I want to delete a relationship next. So let's say I like Python, right? So I want to delete that likes relationship. Oh, before I delete the relationship, let me actually delete the property of a relationship, right? Remove, I can do rel.coding level. So it also removes the intermediate property of this. So when I click, there is no coding level anymore. So we've successfully removed that. All right. Next thing that I want to do, I want to delete the relationship itself, right? How do I do that? I want to go and say, we don't use remove this time. I'm going to use delete, okay? Delete relationship. I actually don't want to delete all the relationships. If I do that, I might delete all the relationships, but I want to specifically delete the likes relationship. So I'm going to choose it here, likes, and delete it. But I wonder if I can even choose it here. Let me try to actually choose it here, relationship, likes, and see if it works. Oh, actually it doesn't work. So I'm gonna go ahead and put the likes on top. All right, if I do that, I think I successfully deleted the relationship between Roma and Python. There is no likes relationship anymore. And if we go back and retrieve everything just like before, we don't see the Python anymore because it's been deleted successfully. I don't like Python now, right? So the Python relationship, likes relationship has been removed, so we don't have it anymore. And how do we delete the node? Let's say I want to delete the Roma node itself. How do I do that? I actually can do it this way. I go ahead and I say delete Roma. Not a property, just the node itself, okay? There is no dot or anything, as you can see. When do I do that? I get an error, cannot delete node 2 because it still has relationships. To delete this node, you must first delete its relationships. In Cypher, there is a keyword called detach. So if I detach that, I will delete the Roma node itself and as well as the relationships that it has, okay? So I'm deleting Roma and I'm forcing the relationships to be deleted as well. And when I do that, Roma doesn't have any relationship anymore. And Roma actually doesn't exist, okay? Let's go ahead and search for Roma. I go where, let's say Roma.name equals to Roma. When I do that, there are no records, so it's not returning anything to me. I wonder if I could search by ID Roma equals to, I think it was 2. Was it 2? I think it was 2. All right, so no changes, no records. Was it actually 2? I think, yeah, it was 2. My ID was 2. Yeah, ID Roma equals to 2. So we deleted that successfully. So far we've deleted a property, we deleted a relationship, and we deleted a node as well. We've learned about the word detach to force delete. When we say detach, it deletes the node and as well as the relationships that it has connected to, okay? And you can actually do the where clause and identify specific nodes and then delete the properties of it. Even you can identify some relationships if you want with where clause and delete the properties of it. You can delete the relationship itself and you can as well as delete the nodes. That's all for the delete part, and we are going to talk about the create part next, and we are going to see how we can actually create data in the database. All right, that's it for this part, and I will see you in another part. All right, welcome back everyone, and in this part of today's session, we are going to talk about create. So far, we've familiarized with how we can read data, update data, delete data, right? And now let's take a look at how we actually can create nodes, relationship, and as well as the properties attached to them. And at the end of today's video, and I want to show you how you can actually connect Neo4J to your own favorite programming language. If you are using like Python or JavaScript, how you can actually use Neo4J inside your programming language, and also how you can connect it to your own application. Without further ado, let's get started. All right, so in today's part, I want to introduce two new keywords for you. They are going to be create and merge. And these keywords are used, these clauses are used just to create data. And they are kind of similar, but except a case when merge actually avoids creating duplicate data. So let's say I'm creating I'm sending create requests with the same given data. If the data has been submitted before, if the data already exists in our database, then it's not going to create the copy of that data. It only creates once. On the other hand, create clause just creates the data even if it's a duplicate, okay? It doesn't really care. So what merge does, we're going to see that in action. Now let's get started with create. So I want to create a new node. I don't want to touch the data that we already have here. So I want to just create a new label and add some nodes to that label, okay? I want to create a label called new student, and I want to name it as student here. What I'm gonna do with the student, I need to give the properties, right? So do you still remember what properties do the students have? They have name. Let's say I want to give it a name of Olivia, and they have age, which is gonna be just 25, and they had a country, right? And let's set it to USA, and there was a created, if I remember, created property, and it's just a timestamp function. What this function does, just it returns like a integer value. Neo4j kind of identifies when the node or relationship has been created. It just remembers the time and the date. And when we do that, we are good to go. You just write create, and you specify the label, and you just give the properties, right? We have several properties here, and I just want to return it after I create it so that we can see it on the screen. And I'm gonna create the data, right? All right, so now we have Olivia. Now we have a new label, and with one node, which is Olivia inside it, right? Now let's use the same thing. Let's just call it twice, and I created Olivia twice, and if I check the database, there are actually two Olivias now. But if I don't want that behavior, and I can actually use merge instead. Let's do merge, and when I merge them, let's say I want to change the name to Alex. When I merge, it actually first checks the database. If Alex already is in the database with the given these properties with the same values, then it's not gonna create it. It's just simply gonna return it, okay? And I'm gonna go ahead. Actually, this created property, this function returns different integers because we are actually like we are running the data at a different time. So it will not be unique then. It's gonna kind of nullify our condition. So I'm gonna get rid of that just because so that you understand how merge works, okay? All right, I'm gonna merge Alex. I'm gonna call it again, and again. Now on top, when I check the database, I only have one Alex. Why is that? Because of the merge, okay? Create actually creates the duplicates. It doesn't really check. If I do create, now let's say Justin. So I'm gonna create it. I click the run button 3 times, so we should have 3 Justins now. So as you can see, 1, 2, 3. So that's the difference between create and merge. All right, so that's how we actually create a node. Create a node with the given properties, okay? So it's gonna the database is gonna give like unique ID automatically so that it uniquely identifies that node, and it has a label of new student. All right, and let's go ahead actually and create a new campus, and I'm gonna call it cam, and we don't have these 8 countries for that one, so I just give it a name of, let's say, Haidian. Okay, and I'm gonna return the campus after I create it. So now we have a new campus with the given property Haidian. All right, so that's how we create a node, and let's actually create a relationship. So let's say in my new students label, I want to connect Justin, all the Justins, to Haidian campus. Okay, so they all live in Haidian campus, let's say. So how do I do that? I actually want to get Justins first, so I'm gonna do all the Justins, new student. I want to filter for name Justin. And now after I have Justins, I can do merge, or I can do create. Oh, I need to get the campus as well. Match campus. So I'm gonna do new campus, and I only want the name, which is Haidian. If I don't provide that, it's gonna take all the campuses. So I don't want to take all the campuses, even though we have one now at the moment in our inside that label for new campus. I just take Haidian 1. Now between these two, I want to create a relationship between Justin's and campus. Okay, so what I'm gonna do, I can even use create, or if I'm gonna stick to merge, because I want to check first if the relationship already exists or not. If already exists, then it's just gonna simply return it. It doesn't create duplicate relationships. All right, so I'm gonna do Justin's, and I'm gonna put the dash here, and then I'm gonna specify the name of the relationship. So I'm gonna say, let's say, Justin's new lives in, maybe new lives in, where do they live in? I put the arrow again. They live in this campus, right? And if we want, we can actually, as I told you, relationships can also have properties, right? So I'm gonna go ahead and give it that property of, let's say, duration. Let's say Justins have been living there for like 3 years. I'm just gonna say 3. Duration in years, so that we can identify this actually demonstrates years. I don't want to make it string. I just make it an integer. So that's how we create relationships. Okay, so if I want, you can even do it the other way. So you can give it a name, and then you can actually do on create set. I don't want to do that way. I want to specify the property just right here after I mention the relationship name. So after I create it, I want to return them. Okay, so I want to return Justin's, so that we can see Justin's. And why did I give it the name of SD? I'm gonna give just the relationship and cam. All right, so if I run this query, now we have relationships from Justin's to Haidian. Okay, they all live in Haidian, and they have the relationship itself has a property of duration in years, which is 3 here. And that's how we actually can create relationships. And that's, I think, pretty straightforward. It's kind of easy, right? And I hope you got the idea. Next, I want to show you how you can actually create or link your application with NEO4J. These are all right. We talked about creating data, updating data, deleting data, and reading data. Now we are good to go. Now we can use Neo4j in our applications. And how do you actually connect your application to Neo4j? That's what we are going to talk about in the next part. All Right, so far we've learned about Neo4j, how we can work with the database, right? Now, in this part of today's session, let's talk about how we can actually connect Neo4j into our own application. If you go to Neo4j documentation website, on the left side, you can see the create applications section, and they have drivers for different programming languages. Let's say if I'm using Python, then I need to install the library with pip install Neo4j, and I can just import it in my own Python program, and then provide my username and password, which I was given from the Neo4j database, right? And then I can do verify connectivity, and from there I can just start writing some queries. So I can do driver.execute query and execute the query, and we have value age here. We are passing it as a context and plug it in here in our application, in our query. And after that, you can get the results. So it will be saved in the records variable. So you can just loop through and print them out. In my case, I'm actually using it with JavaScript, and I want to show you how it works like underneath the hood. I installed the Neo4j driver, and I just gave my username and password. And then I just copy pasted all these queries. Now let me show it to you in my own application so that it makes sense to you. All right, so here I'm exporting the driver. Oh no, actually it's here. Here var Neo4j require Neo4j driver. So it's kind of getting the Neo4j driver from my node modules here. And then I'm passing the URI user password, and these values are being loaded from the environment value, so you cannot see them now. And here, try and catch. Try to connect to the database, get the server information, and then console log the server information with this string, right? And if there is any error, then it just catches the error and prints it, like console logs the error in my application. And when I run my application, when I run my own application now, when I go to the website and when I do the inspect, now here I can see that connection established, and this is the server info. This is kind of console logging everything. And that's how you can connect it in your application with JavaScript. It doesn't really matter if you are using JavaScript, Python, or whatever. It just matters that you go through the documentation and connect it. They use the same logic, only you just need to log into your own application with the password and URI and username. And here what's going on is when actually the user submits the form, like let's say I'm gonna go Roma 23, right? And let's say Zhongguancun again, and I go Python intermediate, and I go right my country. Now here I'm running this code when the user submits the form. Okay, so what I'm doing is I'm plugging in all the values like name. I'm just using these functions here. You don't have to worry about them that much. These are just built-in string functions. I'm just trimming the string, and I'm making it lowercase, all the capital, all the letters, and then I'm capitalizing the name, and I'm passing my country, age, and this is something that we've seen before, right? And on create set, I'm calling the timestamp function so that the Neo4j knows when this node was created. And I'm using all only merge here, not create, because I want to check first for duplicate values. If it exists, then it doesn't have to create one more time. So that's how I plugged in all the values, and I got the students, and I established a connection between them, relationship. So classmates with common class, big data analysis, and merge person, create person, relationship lives in with the campus, right? Person likes coding, and that's how I did this. After that, we can actually console log. And now let's see what happened in our console here. So I'm just console logging the query here. Where did I do that? I did the console log. I think here, yeah, submit information. So it's console logging the query. And that's how I did it in my Vue application. And whatever app or whatever programming language you are using, it depends on you and how you can link it. It's just straightforward. You just execute queries just like you do in Neo4J. And that's all. I think you pretty much grasp the idea of Neo4j and how you can use them in your own apps. And from here, it's up to you how you can use Neo4j for your future big data projects or whatever you do. I love Neo4j, and I'm gonna be using Neo4j for my own applications as well. And that's all for today's session, and I will see you guys next time. Bye bye.